Hey guys, this is Mr. Piercy here, and what we're going to be looking at are going to be the properties of two other types of parallelograms called a rectangle and a square. Now, to help with the uh, length of the video, what I'm giving you here is I'm just giving you the definitions of what a rectangle and a square are. If you looked them up in a high school geometry textbook, the definition of a rectangle is going to tell you that it is a parallelogram that has four right angles. And the definition of a square will be a parallelogram that has four congruent sides and four right angles. So because they're parallelograms, they have all of the characteristics of any other parallelogram. The opposite sides are congruent to each other, they're parallel to each other, and the diagonals bisect each other, the opposite angles are congruent, and the same side angles are supplementary. Now, if you are going to follow along with the investigation, if you have patty paper available, that will be helpful. Otherwise, a compass and a straight edge will be useful to help you see the things that we're going to compare. So what I've done is I've started off with a rectangle and here at the bottom a square. I've constructed them so that they have the characteristics of the definitions. The rectangle does have four right angles and the square does have four congruent sides and four right angles. I just measured them rather than using my compass and straight edge to actually make the congruent segments and the right angles. But so if you need to, if you're going to follow along with these, make sure you draw yourself a square and a rectangle to begin with, and when you're ready, go ahead and hit play again so you can kind of follow along with what we're going to do. Now, let's take my piece of patty paper here, and what I'm going to do is I'm going to copy, uh, trace ABCD onto my patty paper. All right. Now, the purpose of the patty paper again is really just to kind of help us compare things quickly and easily. So this is A, B, C, and D. Now, again, it does have all the characteristics of a parallelogram. The opposite sides are congruent. You can see that very easily. A, B, and C, D are the same. AD and BC are the same length. Uh, and it does have diagonals that are congruent to each other. And we do know that it does have four right angles because if I take, let's say that I take angle A and I put it down here at angle D, I can just kind of flip it and see, well, yeah, the two angles here are the same, and these two angles here are also the same. So if all four angles are the same and they have to have a sum of 360, that means that each angle must be 90 degrees. So that's how we determine the fact that a rectangle is a parallelogram that has four right angles. Now what I'm going to do is I'm going to take my straight edge and I'm going to draw in the two diagonals AC and BD. Now, one of the characteristics that we saw about a rhombus in a previous video is that the diagonals were perpendicular to each other. Well, clearly, I don't have to measure those to say that, well, in this case, these diagonals are not uh, perpendicular to each other. So we don't have right angles there, although we do have right angles inside of the figure, so we do see right triangles that we can use. And anytime I have right triangles, well, maybe that means I have to remember the Pythagorean theorem. Maybe that means I have to remember special right triangle rules. Maybe that means I have to remember trigonometry. So we're going to go ahead and add the diagonals to the tracing paper also. Now, again, if you don't have if you don't have patty paper or anything, this is everything that I'm going to do here is something you can do with your compass and your straight edge also. Now, just a quick check to again confirm that it has the characteristics of a parallelogram. AE and CE, those should be the same because they bisect each other and we can see that they are. Same thing with BE and DE, those are the same. We can see that very easily. Now, So the diagonals are congruent to each other, or the diagonals do bisect each other, but what about the diagonal lengths themselves? Because essentially what we're looking at, like I said, we have four right angles. So this is a leg of a right triangle, this is a leg of a right triangle. So segment AC has to be its hypotenuse. Well, this is a leg that happens to be congruent to this leg, and this leg is shared between the two triangles, so it makes sense that here I would have side angle side congruency, so that means that segment BD also is a hypotenuse of the right triangle, and if the two triangles have the same legs, the hypotenuse must be the same. So what do we do? I'm going to take the patty paper and I'm going to put segment AC on top of segment BD so we can compare the lengths and see, yeah, the diagonals of a rectangle are congruent to each other. So that is in addition to the fact that it has four right angles. In this case, the diagonals are going to be congruent to each other, and that's one of the unique characteristics about a rectangle. So now let's take a look at our square. Remember, a square by definition is a parallelogram that has four right angles and four congruent sides. So I'm going to take one more piece of patty paper here, and I'm going to go ahead and trace that on. Okay, so we have L, M, uh-oh.
Just a reminder, the large leadership meeting is getting ready to begin.
I don't know if you could hear that, but there's an announcement over my school's PA saying that there's a meeting getting ready to start, and I'm glad I'm not in it. All right. So how do I know that, first of all, I made that it does have right angles? So again, I'm going to just kind of rotate a little bit. So let's take a look at angle L and angle O. Okay. So if I flip it so that angle L and angle O sit on top of each other, we can see that those are the same. Same thing with these two angles here. And if it does have a sum of 360 where all four angles are the same, the only way that can happen is if they're all 90 degrees. So we do have 90-degree angles. We can compare the sides opposite of each other and show that they're the same. So yes, this is a parallelogram. But let's add the diagonals here, because this is where we start to see some even more unique things about a square. And again, at this level of geometry instruction, almost nobody is going to come into a high school geometry class without some idea of what a rectangle and a square are. Okay, but there's a little bit more to it than what you may have been exposed to previously. All right, so I've added the diagonal lines here, and so the definition of a rhombus is that it is a parallelogram that has four congruent sides. So that fits the definition of, or at least half of the definition of a square. So does a square have the same characteristics, all of the characteristics of a rhombus? One of the things that we notice about a rhombus is that the diagonals are perpendicular to each other. So now I'm going to take my patty paper, now that I have the diagonals on here, and I'm going to rotate it 90 degrees and compare the diagonals. And we say, oh, yeah, the diagonals lay directly on top of each other when I rotate it 90 degrees. So that means that the diagonals are indeed perpendicular to each other, which is a characteristic of a rhombus. Well, one of the other things that we notice about a rhombus is that the diagonals bisected the angles opposite of it. So I'm going to take this point here, L, and I'm going to move it over here to N and compare the angles, and we see that the two angles here at L and at N are the same, and we can kind of compare it here at M and O. So this is point O on the, well, so we can kind of move it here so that way point M and O are laying on top of each other now, and we can also kind of compare those and see, yeah, uh, these angles do get bisected by the diagonals. So all of the interior angles will get bisected equally by the angles, which, essentially gives me four 45, 45, 90 triangles inside of the square with which to work if I needed to. So it does have uh, perpendicular diagonals. It does have uh, diagonals. It does have diagonals that bisect the interior angles, and it has four congruent sides, and it has four right angles, meaning specifically when I say the right angles, I'm meaning the interior angles of the polygon, not anything formed by the diagonals. So a square has all of the characteristics of a rhombus, and it has, for sure, it has four right angles, so it has the characteristics of a rectangle. But the other thing that we need to know for to be a rectangle is, are the diagonals congruent to each other? So here we look at LN and we look at OM, and we turn the paper over and we can see that, yeah, the diagonals are congruent to each other. So it also has congruent diagonals. So that allows me to conclude that a square, I can't spell today, not a skewer, it has, because a square has all of the characteristics of a rhombus and it has all the characteristics of a rectangle, we say a square is a rhombus and a rectangle at the same time. Now that doesn't mean that every rhombus is a square and that every rectangle is a square, but it does mean that every square is a rhombus and every square is a rectangle. So those are the characteristics that we're looking at for rectangles and squares. Rectangles have parallelogram that's four right angles that has congruent diagonals, and a square is a parallelogram that has everything that a rhombus and everything that a rectangle has, and everything that a parallelogram has. So that's quite a bit of information there, but those are why, when we see our notes, that's we're going to see the why or the how, and this is the why. So I just want you guys to make sure that you see where things come from, rather than just say, "Oh, well, Mr. Piercy was a teacher. Why would he lie to us?" But